Hello everyone. Today we are going to discuss about linked list, introduction to linked list, and various types of linked list and their implementation. Okay, we'll see everything clearly. Uh, so, what are the limitations of an array? So first, before going to see about the linked list, we should know why this linked list came into existence. What is there earlier before this linked list? What is there earlier? What are the drawbacks of that one? So we will see that and we'll move to the linked list also. Okay. Before this linked list, we are having another linear data structure called as arrays. Okay, as I already told you that in the previous session, I told you array is a collection of homogeneous types of elements. Same type of elements are placed, okay, one after the other. So same type. So we call it as arrays. So what are the drawbacks of arrays means? So here we mainly concentrate on two major drawbacks. One is fixed size. Okay, so whenever you declare as an array, whenever you declare as an array, so you declare an array. For example, let us take int a of 5. So that means you can take up to 5 integer elements. So you can store only five elements. Suppose if you want to increase the size of an array, so at the time it is difficult. Why? Because array size is fixed. You can store only 5 elements. So you can store one element, two element, three element, but maximum you can store up to 5 elements. If you want to change, if you want to resize it, so it is difficult. Okay. So this is one drawback of arrays. So again, you need to reinitialize the data structure. You need to reinitialize the array. Okay. And the second drawback of arrays is whenever you are placing the elements one after the other, you will be, for example, let us take if you have stored five elements 10, 20, 30, 40, 50. Okay. So you place all these elements one after that. Suppose if you want to insert an element 25 in the array at some position, then you need to shift all the elements. So either you need to shift all the elements top or down to place this element at the particular location. Okay, so this is also a huge task for shifting all the elements. So these are the two main drawbacks of arrays. Okay, so to overcome these drawbacks, we got a concept called linked list. So this linked list, it provides, it overcomes these two drawbacks. It how it overcomes it? Here linked list is nothing but it consists of nodes. Okay, so here we'll be taking the dynamic side. So we can create n number of nodes. Suppose if you have taken 10 nodes, so you can add one more node, 11. You can add one more, something like that. You can dynamically you can increase the size of a linked list. Okay, this is the drawback in the array. You can't increase the size of an array. Then not only that, the second drawback of array is we can't, if you are trying to insert an element or deleting an element, you should shift lot of data. If you if you consider this linked list, no need of that much heavy task you need to perform. It is easy to insert an element or delete an element from a linked list. Okay, these are the advantages of linked list over arrays. Okay, and then, as said, a node or a linked list consists of nodes. So, what does this node consist of? A linked list, if you observe the definition of linked list, a linked list is an ordered sequence of items. So, it is also a sequential data structure only. It is also a linear data structure only. We are placing the elements in a ordered, okay, ordered sequence of items. What are those items? We are calling them as nodes. Okay, so each node consists of two parts. Each node consists of two pods. If it is a single linked list, so it consists of one link pod and one data pod. Okay, so a node is a singly linked list, consists of two fields, a data pod and a link pod. What does this data pod consist of? So whatever the data you are collecting, that will be stored in the data pod. Okay, in the link pod, you are storing the address of next node. Address of next node is stored in the link pod. Okay, so finally it says a node is a basic unit of representation in a linked list. In a linked list, you are representing the data in the form of nodes only. Okay, so if you observe a train, if you observe a general example, a train, first it consists of an engine followed by many number of compartments. Okay, one compartment is connected with another compartment. Okay, another compartment is connected with another up to the last compartment. Okay, so last compartment means next no compartment is there. It is the end of the train. Okay, similarly here we are placing our data in the form of a list which consists of nodes. Okay, so these nodes are placed sequentially. So this node, as I said, node consists of two pods, data pod and link pod. If you observe here, this is the data pod and link pod. Data pod holds the address of the, data pod holds the actual information what we are going to store, and link pod holds the address of next node. Okay, so in this way we are representing a node. So what are the types of linked lists? So we are having different types of linked lists. So singly linked list, double linked list, circular linked list. Okay, so we mainly divide these linked lists into these three types: singly linked list, double linked list, and circular linked list. So we are having another thing called double circular linked list also. But we mainly concentrate on these three things. So what is this single linked list? So single linked list means the name itself, it is saying a linked list which consists of nodes, a node which consists of only one link, a linked list with one link pod and one data pod. Okay, single linked list means a linked list with one link pod and one data pod. Whereas double linked list means a linked list with two link pods and one data pod. We'll be having two link pods and one data pod. So in the two link pods, in the both the two link pods will be storing the address. Okay, so in the first link pod, in the front link pod, we'll be storing the address of previous node. Okay, in the second link pod, we'll be storing the address of next node. Okay, we'll be storing the address of both the nodes, which is previous node and next node. In the middle, we'll be placing the data. In the middle, we'll be placing the actual data. We'll be storing the actual data. Okay, so in both the cases, in single linked list and in double linked list, the last node. So if you observe the last node, after that node, there are no more nodes. So in the link part of the last node, we'll be placing null. It represents that is the end of the node. That is the end of the list. Whereas in circular linked list, so we are not placing the null there at the last node. Instead, this last node points to the first node. We will be storing the address of first node in the last node. That's why we are calling it as circular linked list. Okay, we'll see this with a diagrammatical representation. Observe here. This is my first node. So actual data 5 is stored here. So here I am storing the address of next node. The address of 10 is stored here. Similarly, the address of 15 is stored here. Similarly, the address of 20 is stored here. Observe here, after that, there are no more nodes. That's why we are placing here as null. Null represents empty. That is a last node. Okay. So this is about single linked list. Similarly, double linked list. If you see the double linked list, so here there are two address parts. One is one stores the address of previous node and the other stores the address of next node. Okay, as this is the first node, there is no previous node. That's why we are placing here as null. Okay, so 5 here this is the actual data. So here I am storing the address of 10. So here I am storing the address of 5. Okay, similarly here I am storing the address of 15. Here I am storing the address of 10. Okay, so on the in the last node, so we are not having no more nodes after that. That's why we are placing here as null. Okay, so this is about single linked list and double linked list. Now let's if you see about circular linked list, instead of placing null here, we are giving an address of first node information. Okay, if the last node again points to the first node, then we will say it as circular linked list. Okay, is that clear? So single linked list which consists of only one link part, double linked list which consists of two link parts and one data part, circular linked list where last node points to the first node. Okay, now let's see clearly. So what are the basic operations that are performed on single list? As I said, the definition of data structure itself, the way of organizing the data, we have seen how we are going to place the data. Now, what are the operations we are going to perform on the data structure? So on the single linked list, what are the operations we are going to perform? Here, we are observing, we can create a list. Okay, first we need to create a list. After creating a list, so this list consists of lot of elements, one after the other. Okay, now the second operation is traversing the list. So if you are visiting each and every node in the list, if you are visiting each and every node in the list, we will say it as traversing the list. Okay, you are visiting and you are displaying what is there in that node. Then inserting an element into the list. You are trying to insert an element into the list. Already a list is there. You are trying to insert. Okay, already a list of elements are there. So you got a new element. We are trying to insert at one position. Okay, we will see how we are going to insert it. Similarly, deleting an element from the list. How we are going to delete an item from the list. Okay. Finally, concatenating two lists. Suppose if you take two lists, I can merge these two lists. Okay, I can merge these two lists and I can form one list completely. Okay, so these are the various operations we are going to perform on single list. Let's see all these things clearly with examples. Okay, yeah, first how we are going to create a node. So these the basic instructions we need to know. First, this is the node structure. So it consists of data, and as it is not pointing to any other node, that's why we are placing here as none or null. We can say it as null. Okay, that's why here self dot data. So self is this node. Self dot data equal to data. Whatever the value you are giving. Suppose if you give 5, suppose if you give 10. Okay, so 10 is assigned at this position, at data position. And here I am placing none. First, nothing is there. Data, nothing is there. I'll be taking an empty node. So there I am placing the data, whatever I'm going to take, and I'm placing the none. Okay, null. Then this is a simple thing. See here, I am trying to create three nodes in a list. Okay, so I am taking the n value, how many number of nodes. So I'll be taking three. So starting from my first node to last node. That means 0, 1, 2. So as it ranges from 0, 1, 2. So we'll be having three nodes. So I'll be reading all the values. So what I need to store in each node. Okay. So for in each node, I need to give the data. I need to give the data, and I'm going to store it. Okay. So in this way, I'm going to create. If nothing is there, first I'll be creating. I'll be taking a node. In that node, I'm going to give the data and I'm going to give the none part. If already a list is there, if already a list is there, what I need to do? So I need to go up to end. I need to move from starting node to last node. Observe, suppose if you take the same example of train. So already a train with a engine and some 4 compartments are there. Let us think like, okay. Now you are trying to insert one more node. So first, so we are talking about creation. Creation means, so nothing is there. I need to create a train. I need to show a train. That means first I should have an engine followed by compartment. Okay, I'll be taking a compartment. Similarly, here also I'll be taking a node. So in that node, I'll be taking the data. Okay. Similarly, I'm taking all the nodes. First of all, I'm taking all the nodes. Then I'll form a link between all these nodes. Okay. So observe here, if self dot start equal to none, if nothing is there, if nothing is there in the list, if the list is empty, if the list is empty, so the first node, whatever I'm taking, that node itself is the starting. Okay, so whatever the new node I'm taking, that node itself is the starting. If nothing is there, if the list is empty, this is the thing. Suppose if already there are elements in the list, if already there are elements in the list, what I need to do? I need to move from starting node to last node, and at last node I am going to insert my element. Okay, so that's why I have taken some something called the first node. I'm calling it as temp. First node I'm calling it as temp, and I'm moving my temp from first node to next node. Okay, similarly I'm moving from first node, second node, third node, up to last. So now my last node is temp. If it is none, if it is nil, okay, if it is nil means that is the last node. Okay, if that is the last node, there I need to create, there I need to insert my list. Sorry, insert my node. Okay, it'll be clear if you see the diagrams. Don't worry, I'll make it clear. See here, creation of first node. So first, this is my new node. I have taken a new node. So in that, I have taken some information 21. So nothing is there. Just I'm just placing null. Okay, so which represents the nothing is there after this node. This is the end of the node. Okay, so I need to give the address of this somewhere like here, like engine. I'm taking it as a start or a head. We'll say it as head node. Okay, so head node, start node. We'll say in a different way. So similarly, in this way, I'm going to create my first node. Okay. So then insertion of a node at tail. That means at end. See, observe here. Yeah, observe here. Already I have taken some elements 21 and 22. So yeah, 21 and the address of this 22. What is the address of 22? 3000. 3000 is stored here. Okay, so the address of 21 is 2000. 2000 is stored here. Okay, in this way I'm representing a linked list. Now here none is there. None is there means it is the end of the linked list. It is the end of the linked list. That is the last node. Now what is our aim? I need to insert an element at the end. Here I am going to insert the element. Here I am going to place the node. That means the address of new node has to be placed here instead of none. So I am going to take the address of next node. Observe here, I have taken a new node 23. The address of that node is 4000. That 4000 should be placed here. So I'm just removing this none, and I am placing my new node address 4000. Okay, in this way I'm going to insert an element at the end. So as I already told you, there are a lot of operations performed on single list. So like addition, insertion, deletion, traversing. So here insertion, again, there are three cases. Am I inserting my node at the front position? So I have taken a node. Okay. Am I inserting that node at the front position? Or am I inserting that node at the end, at the last position? Okay, so maybe I'm inserting at the front, or maybe I'm inserting at end, or maybe I'm inserting at some position. So if you observe this second point, insert a node after a given node. I'm giving a position. So you just insert this node after this node. So I'm giving a position. There I'm trying to insert. Okay, so these are the three ways we need to consider while inserting. Similarly, in the deletion also, we are having the three ways. So deleting the node at front, I mean deleting the node at beginning, deleting the node at end, and deleting the node at given position. Okay, so these are the three ways. So, however, we have seen the addition of node. Similarly, we'll be seeing the deletion of node also. Okay, so observe here, inserting a node at the beginning. So we are having A, B, C, D. Already a list is there. Okay. So actually head is pointing to A first of all. Before inserting, head is pointing to A. Then here I am storing the address of B. Here I am storing the address of C. Here I am storing the address of D. Here nothing is there. That's why I am placing it as null. So that is the end of the node. Now my aim is to insert node at beginning. That means before A, I should insert the element. So that for that purpose, first I should break the link between this head and first node. Okay, I should remove that and I'll take a new node which I need to insert. So that head is pointed to the new node now. I hope it is clear. So earlier head is pointing to A. Now head is pointing to the new node. In the new node address part, I'm going to store the address of A. Okay, now it starts from here. E, A, B, C, D. Okay, in this way I'm inserting the node at the beginning. Similarly, yeah, these are the steps. Whatever I said now, so I just written it in program format. Okay, it's very simple that I have taken a node, I have taken some value. If that is my starting node, I just I just say that is my starting node. Otherwise, I have to remove this link part and I have to point this head node to the first node. Okay, that is what I have given there. Yeah, observe here. So I have taken a new node 20. So earlier the list is like this. So 2000, 21, 22. So 21, the address is 3000. Next node the address is 3000. The address of 2000 is stored here. Okay, this is the first list I'm having. Now what I am trying to do is I'm trying to insert 20. Insert a node at beginning. Beginning means here I need to get. Okay, so for that I'll just remove this link and I'll be placing the node here. Here I will be storing the address of 2000. I mean address of 21. 2000 is placed here. This one is placed. The address of 5000 should be placed here. Okay, observe here. So 5000 came here and 2000 came here. Okay, so it's very simple if you see the pictures clearly. Okay. So similarly, now coming to the inserting a node at the end. At the end means last node. Okay, I need to go to the last node. Starting is A, B, C, D. So this is my last node. First, I thought that this is my last node. Nothing is there. So this is my last node. I place here as null. Now I'm trying to insert a node E. I'm trying to insert a node E. It should be inserted at N. Okay. So that means here I have to remove my null part and I have to store the address of E here. Okay. So these are the steps. So until my last node, I will be moving from my first node to last. Okay, this is my else part. So while temp of next not equal to null. So until I found null, I'll be moving from first node to last node. So as I found null here, I stopped here. So what I'm doing, I'm just inserting my new node at this location. Okay, see the animation, you'll be getting clear idea. So this is my list. So this is my last node. That's why here none. So now I need to insert 20 here. I need to remove none and I need to place the address of 20. That means 5000 should be placed there. So here, so this is the last. That's why I'm placing here as none. Okay. So I hope it is clear. I'm trying to insert a node at the end. Okay. So inserting a node at given position. So now I inserted the element at the beginning as well as at the end. Now my aim is to insert a node at some position, maybe in between B and C or C and D. So I'm just asking where I need to insert. I need to take the position. After finding the position, I need to move. I need to move to that location. Okay. Suppose if I said at second position. Okay. Second position means this is 0, this is 1, this is second position. At C position, I have to insert. So that is what here I have shown. First, I am taking the position. Up to that position, I need to move from first node to that position. So after moving to that position, so simply what I am doing is, this is my new node. This is my new node. So I'll just simply break this link and here I am going to store the address of E and here I am going to store the address of C. Okay, very simple thing. Just I am removing the address of C here. So the address of C is placed actually here. So now I am trying to insert a node in between B and C. So I am just taking a node E. So I'll remove this link and the address of E will be stored here. The address of C will be stored here. Okay. Observe the animation, you will get a clear idea. So this is my list 21, 22. And now I'm trying to insert 20 in between 21 and 22. I'm taking the position. So I'm reading the position. So in between those two things, I'm just inserting my node. Okay. The address of 5000 is placed here and the address of 3000 is placed. Okay. This is about your single linked list insertion. Okay. Similarly, deleting a node. So we have seen only inserting a node up to now. Okay. Let's see simple thing about deleting a node. Here also, as I already told you, there are three ways. One is deleting a node at beginning, deleting a node at end, and deleting a node at given position. Okay. See here. So this is the actual list of 1, 2, 3. All elements are there. Now I'm trying to delete a node at beginning. Trying to delete the node at beginning means I'm just removing the first node. I'm just removing the first node. So now it becomes the starting node. So this is very simple. Deleting a node at beginning means, so just removing the first node and the next node becomes the starting node. Okay. See the animation, you will get a clear idea. First, the list is like this: 2021, 22. Okay. So what I'm doing is I'm trying to delete this. If I'm trying to delete this, so here I need to get the address as 3000. Okay. Yeah, observe here. I just got 3000. I'm just removing this. Okay. Similarly, deleting a node at the last position. So last position means, see here 10, 20, 30, 40, 50. Okay, for 40. So in this list, we are having 4 elements 10, 20, 30, 40. And here I am giving a null. Okay, this is my end of the node. So now I am trying to delete a node at the last position. This is very simple now. If you are deleting, so what we need to do is we simply place, we'll remove the last node. So before this, actually here the address of 50 is there. Okay, we'll just remove that 50 and the address here. I'm just placing null so that is it deleted. Okay, so those are the steps we have written. So earlier 21, 22 is there. I need to delete this 22. So here I am placing the address of 3000. So after deleting this 22, here I should get null. Okay. You will be getting none there, and this node will be completely deleted. Okay. Deleting a node at given position. I am deleting the node. See, observe here, A, B, C, D is there. So I am taking the position, which one I have to delete. So I am moving to that position. I am counting. And I am moving to that position. Okay. So after going to that position, suppose if I am trying to delete second position, so 0, 1, 2. See, that means C is the second position. I need to delete this. So if I am trying to delete this, what I need to do before deleting, first I should break the links. Okay, so I should place the link of address of DA here in the address part of B. Here I need to store the address of D. Okay, simply I'm deleting this. So you'll be getting A, B, D. Okay. See here 21, 22, 23. So it is normally we are having like this normal list. Now I am trying to delete the element at second position. Okay, so that means 22. This one has to be removed. So 21. I'm just removing it. So here I'm storing the address of this one 23. Okay. So in this way, I'm deleting the elements at given position. So similarly, traverse or display. Traverse or display both are same, where we are visiting each and every node in the list. So we'll move from starting node. So here I am displaying the value 21. Then we'll move to the next node. Here I am displaying 22. Then 23. That means visiting each and every node in the list, we call it as a traverse. Okay, until the last node, I need to move and I need to display the data. Okay, so those are the things that are given. Okay, see, observe here. Until last node, I'll be displaying my temp of data. Yeah, finally, what are the drawbacks of linked list? So I said linked list. I have seen. I have seen. We have seen a lot of advantage of linked list over arrays, but still there are drawbacks of linked list. You say. So what are those drawbacks? Means extra memory space for a pointer is required. Okay, we are storing the data. Not only data, we are storing the address part also. Okay, for that pointer also we are allocating memory. So that is extra memory space is saying. And random access is not allowed. So here random access is not allowed. So directly we can't go. We'll move from first first element to next element, next element to next element, something like this. Okay, we have to access element sequence starting from my first node. Nodes are stored incontiguously. That means they are not stored one after the other. There is no connection. I mean, they are not sequentially placed. So they are data is linked lists are scattered, but it looks like they are placed one after the other, but they are not placed sequentially. So for getting the elements, it takes some time. So That is also one drawback of linked list. I hope it is clear about the concept of a linked list. Okay. Thank you. Thank you, everyone.